Okay, ready for the afternoon, guys. We have the next speaker, which is Alessandro Cifani. So, we asked Alessandro a fun fact about him, and the answer was, quote, "I enjoy reading tech documentation and find it relaxing." So imagine Alessandro turns off the computer after a long day of meetings, a 4-hour meeting, then exhausted, picks up the phone, lands on the couch, puts on phones with lo-fi music, and then, let me get Element by ID.
Webpack is my favorite, by the way.
Webpack,
Yeah.
version 2, yeah. Okay, anyway, he will talk about monorepos, so
Exactly.
please enjoy his talk.
Hey. Hi, everybody. Hi. This is my first public talk, so as you can imagine, I'm really not anxious at all. Feel very natural here. And also thanks to the organization for trusting me, and sorry in advance. But yeah, here goes nothing. So I hate waiting, right? And I think as a developer, it's the one thing that I hate the most, right? I hate slow websites, slow apps, but most of all, I hate to wait on builds and tests, linters, and please raise your hand if you feel the same about hating the wait. Yeah, I imagine everybody else is sadistic, I think, but yeah. So I hate waiting, right? And this journey, the Subito journey, will all resolve about waiting. This journey starts in 2017, which was really a buzzing year to be a web developer, because you had React and TypeScript on the rise, so they were gaining more and more popularity everywhere, and then would go on to basically conquer the world. Also, GraphQL was the newborn star and was also getting more popular by the day. And also Next.js was less than a year old, so very promising there. And also Brexit started to happen, and so, which was nice. And by the way, since I prepared this slide, UK government changed twice, so yeah, that turned out well. Anyway, Subito in 2017, of course, being great tech company, right, was on top of all of this trend, using the cool stack and everything. Not really, no. As you can imagine, we were still building custom Apache modules in C. Our front end was mostly made with jQuery. We had PHP here and there. But my favorite thing was that we also had a custom template language to print HTML and stuff. And since there was no debugger for this custom language, what we will do is we will print all the local variables in the page to try to understand what was happening, right? And this is how we did it. I'm not kidding. You can ask Subito developers here, the ones with the gray hair, at least, they will know. So as you can imagine, it was no easy task being a developer in Subito. Also, of course, if you know anything about C, is that it takes forever to compile. And with that also came that we had to do manual releases and everything. So, of course, we had no CI and no CD at all. And because we had no CI, no CD, we couldn't deploy automatically. We had to do manual releases, so developers would stay late in the night, buy a pizza, and release, and do manual tests before everything worked out, and then they could go to sleep. And all of this meant that our time to ship features to user were pretty long, okay? And I told you, first thing I told you is that I hate waiting. So we added that, we added how much time it took to release something to our users. So we thought, how can we improve this without having to rewrite everything, which I know is hard to do. So we thought, what if we start injecting basically small React components here and there at runtime? Okay, so without involving the main application, let's just deploy React components in the page, okay? Fetched a runtime from a remote script. And if that sounds familiar, it's because basically micro frontends in 2017, way before they were cool. So Luca Mezzalira's got nothing on us. Sorry, Luca, kidding, I love you. Anyway, this is how one worked in practice. So you will first put up, let's say, the placeholder for the component in the HTML. You give an ID, you could pass props to the actual React components. Technically, we were using p-React, not React, but yeah. You could pass props to the component. In this case, I'm passing the prop called username with Alessandro as a value, okay? And then on the application, you will load your regular JavaScript, and then first you needed to initialize what we call context, which meant shared vendor and other code, for example, like p-React itself and other common libraries. And then you can call the loader render function. And this is where the magic happened. The loader render basically would fetch the component from a remote S3 bucket. You will get always the latest version and render it on the given ID. So what it meant is that we could release these components without touching the legacy applications at all, right? So this took the time it took to ship a feature to users from weeks to hours, okay? So it was huge for us. And actually, they worked really well, but they did have one issue, which was at runtime, because they were fetched at runtime, you can see at the top, it will take some time to load, actually a long time, yeah. The rest of the page was server-side rendered, like with the legacy stack and everything, so it will appear instantly, but that component took really long time, right? Because first, as I told you, we'll need to execute and load and execute the JavaScript from the actual application, and then it would fetch the component and render it, which was very not ideal, right? Of course, the GIF slowed down. Nobody would release that in production, right? Not at all. But as I told you, I hate waiting. So that was not acceptable for us. So a couple of years went by, and then we finally had the opportunity to try to fix this, which was, we thought, by server-side rendering everything, okay? So because they cannot be server-side rendered by themselves, we started to adopt Next.js. We wrote at first a single page, and then we went on to write other pages in Next.js with the given proficiency that we accumulated over the years with React. And we moved all the client-side components to regular NPM packages, which was very easy because they were already React components, basically. So we just had to extract them to NPM packages. But there were some issues because each package now lived in their own repository. We had standardization issues, okay? Because we had each shared package, each library, each everything at their own repository. So how do you standardize everything? It was very hard. It was all over the place. We had many repositories and so on. And with many repository also came very poor visibility and discoverability, okay? It was hard for single developers to understand how many repositories we had, what they did, each of them, and also what dependencies, which is the tricky part, what dependencies were between one another, right? And all this meant that code was hard to change, especially between dependency. If you had like a breaking change, you had to go and upgrade and make manual adjustment on each repositories. And it also happened that you did breaking changes without noticing, right? It can happen by mistake, and you only notice it when you go and update another package. Then you need to go back and fix it and re-upgrade again. So one example, let's say we want to release a bug fix, which is in our hooks library, okay? So we first open a PR there in the hooks library, and we fix the bug or whatever. Then we will need to go to all the libraries that use hooks, for example, our design system, the UI package, and all the other libraries, open a PR, upgrade it, and go ahead. Now, the UI package is used in the header amongst other packages. So we also had to open a PR there and upgrade the package and so on. And then finally, we could open the PR on the Next.js application to upgrade the header and everything else. Okay, so it took many PRs, many time. It was very frustrating, and this was only to ship a single feature to actual users, right? And I told you, I hate waiting. So we really hated this way of working. It took a very long time, was frustrating at times. So we decided, how can we fix this? We thought, how can we fix this? The first thing that came to our mind was monorepo, right? You put everything together. So we started a POC with Lerna, which was all the rage back in the days. This is now, I think, 3 years ago, start of 2019. And we used all the cool tech that the cool kids were using, so Storybook, Rollup, TypeScript, yada yada, a lot of stuff. And the first thing we, as a teams of the platform engineering squad, was how do we ensure that everything works in the same way? How do we ensure that we avoid the same issues? And we decided to create a so-called golden path. So the golden path, you might have heard it from Spotify and other people. Basically, golden path in a monorepo is basically a collection, a set of best standard practices, okay? And as platform engineer, if you put everyone on the golden path, then awesome things can happen. Because everyone is using the same technology and the same tools, first of all, it's easier for users of the monorepo to onboard, because everything is ready for you. You can develop a single script that can create packages and so on. And then you also get all the upgrades and new features basically for free, because the platform engineering will optimize towards people in the golden path. You could also choose to not be in the golden path. You could choose to use your own bundler. For example, if you don't like Rollup or something else, you could choose your own bundler, but then it meant you were on your own. You had to do all the maintenance and so on. So for us, for the platform engineering, creating this meant that every new feature that we developed, all the packages in the monorepo will automatically be onboarded without having to do anything special, because it was all standard, right? So if any of you is working in platform engineering, please take this home. This is, I think, the greatest advice I could give you. Create a golden path so that everything then is easier. And what did we actually do to try to solve the issues at the talk? So visibility, standardization, etc. So standardization, as I told you, being in a monorepo is already enough to solve most of the standardization issues, because then you have a centralized tooling, right? So you have everything there. There is a single configuration which you basically can derive everything else from. So this is like 90% of the work. So that was good enough for now. And then we moved on to the visibility issue, and we worked on a centralized repository, so like a single point where every front-end developer could access all the info about the monorepo. So we built an automated documentation with MDX, in which we added like how to use the monorepo, how to onboard on all the features, design guidelines. Of course, there were all the documentation about the single packages, which was added automatically. And also we built a package index, so that if you open the index, you will see a list of all the packages in the monorepo. You will see a description, an ownership, what they did. And we read all of that from the package.json and some custom metadata. Then we moved on to making things easier to change and improve the time it took to release to production. The first thing we did was try to automate everything, okay? Try to eliminate as much manual work by all developers. So the first thing, before going to the monorepo, you will actually need to manually bump the version of each package. Then you will need to release it to our internal NPM registry. So first thing we did was eliminate that. So thanks to Lerna and conventional commits, which, if you don't know, is basically a spec on how to write commit messages. Lerna was able to understand what kind of version bump they will need to do. So for example, if you wrote fix, it will understand that it will be a patch. If you wrote fit, it will be a minor update, and then for breaking changes, it's a bit more difficult, but could also understand that. So by eliminating, this very small thing, but then used by a lot of developers, then you get, I think, increasing value over time. Because small thing, but done very often. Another thing that we did, and highly requested feature, was PR builds for Storybook. So now when you open a new PR in the monorepo and you add a specified label, you will get a URL with the build from Storybook published. Then you can take this URL and share it to our designers or other developers, whoever you want, to basically check the changes before actually merging. So it was much easier, much nicer to spot errors and discrepancies and problems before actually merging even in the monorepo, let alone upgrading in the app. So people loved all of those features. You can see here, it's a graph of the lines of code that we had in the monorepo since the beginning. So people loved it and started writing new packages, importing packages, and so on. One thing that happens when you have more and more code in your repository is that also your build times will increase. This is a graph on the build duration on the same period. So you will see they increased a lot during that time. And if you notice, they will actually very similar trend. Okay, this is because, oops, spoiler, build times scaled linearly with lines of code. Okay, so 5 times the code meant 5 times the build times. And as you know, I hate waiting. So how can we fix this? Okay, this was starting to become really unacceptable. I mean, if you open a PR and then merge, you could go have lunch and then come back, and maybe you could upgrade packages in your app, maybe not, who knows. So first thing we did was, let's try to build less stuff. Let's try to build only the stuff that changed since the last merge to master. This was pretty easy to do with Lerna. You just needed to add the little scenes at the end. So you will basically see what code changed since the last release and only build that. And this worked really well when only a few packages changed. So build times were great, but actually we noticed that when a lot of packages did change, build times were worse than with building everything. So yeah, we had to revert that because the average time actually went up instead of going down, even if some PRs were really quick, others were really, really long. So we thought maybe we need to approach this from a different angle. Maybe we need to change the structure of how we actually run the CI. So this is how we run the CI back in the days. It's pretty easy and linear. Everything is sequential. So you start by building and then testing, and then you build and publish the storybook, and then you build and publish the NPM packages. So far, so easy. How could we approach this? We thought parallelization. Having sequential builds is not very efficient, right? You have to wait for the task before the other to finish before you can start doing something else, which is by definition not very efficient, at least if you have a lot of computing powers on your end, right? First, let me tell you why we needed to do things sequentially in the first place. So you know that the header package depends on the UI package, right? So if you wrote a test that for the header, for example, then we'll include the UI package. And via regular node module inclusion, we'll go in the package.json of the UI package, see what main or module had, and then include the file. Okay, so we needed those files to be there to run tests, otherwise they would break. But if we want to run things in parallel, then we couldn't use those files, right? Because they wouldn't be there because the build would be running in parallel. Okay, so we needed to find a way to go directly to the source without going through the build files. And luckily for us, with Jest, this is really easy. You can use the module name mapper property, and even though the regex looks scary, what it does is that it takes the name of the package, which is everything that comes after @subito/, and basically when you import the thing, it will replace the import with the path of the source directory, okay, automatically. So this meant that we could go from this to running tests and build in parallel. And after the build and the test, we could run the publish and the storybook, because those two tasks still depended on the build, so we couldn't run them without the builds. So it meant that these two blue blocks could be run, everything in the blocks could be run in parallel, but the two blocks were then sequential. And this was by itself amazing. It reduced our build times from over 20 minutes to under 10, which is, I think, for all of us was really great. We had less time to do lunch though, so not that great. But we knew also that we could gain some other time. Okay, we knew there was some other things to be done to gain even more time. So what we thought was, what if we parallelize even more? Okay, what if we parallelize tests? And this is what test sharding comes in. Starting from Jest version 28, now we 29, so the last major, you can use shards. Okay, test shards. A shard basically is a set of tests that is deterministic. So it means that it will always contain the same tests. So for example, here I'm running 5 different shards, and if you have like 500 tests, each shard will contain 100 tests, and always the same 100 tests. So what it means is that this allows you to run the shards on different machines or different computers or different jobs. In the case of CI, you'll be assured that all the tests have been run because Jest is able to deterministically decide which test to run on each shard. So now we didn't have a single test job anymore, we had many, okay? And this basically reduced our test times dramatically. But still, there was an issue because the storybook and publish test still couldn't run without the build having finished. So now the build was the bottleneck, because the test, we could basically make them last how we wanted, okay? Because we could just, fire 100 shards and they would run in like 30 seconds and we'd be fine. But the build, it was much harder, and it was our bottleneck at the time. So we thought, how can we fix this? Luckily for us, there was about the time that TurboRepo came out from Wurzel. So we trusted the company that bought TurboRepo because we were using Next.js, and they added remote caching, which we jumped right into. We developed our own server, let's say, and we are storing cache artifacts in our shared S3 bucket. And the way it works is basically all the clients can point to the same server and get the shared artifacts cached from there. So for example, how can you see here on the left, you can see the first client is running the build, will publish an artifact and store it to the centralized cache. Okay, the other 2 clients, which are different machines, different everything, when running the build, they will be able to fetch the cache from the centralized storage, making the build basically instant, okay? Because they don't have to run anything locally. They will just fetch all the artifacts and will also get output logs as a nice add-on. So basically, is it as if they will replay the build on their machines, but without actually running it. And this, for us, made it basically builds almost instantaneous. So this is actually, I ran it yesterday, and out of the 4 seconds, probably 3 of them are because my internet really not that great. You could probably bring that down even more. And also another nice little thing that we have is that it also works for partial builds, okay? So if you only have, for example, if you're only changing some packages, we'll automatically still get the cache for the packages that didn't change, but rebuild the packages that did change and their dependencies, okay? And this was really major for us. By back of the napkin calculation, basically we noticed that with this feature alone, so only with remote caching, we saved over 1,000 developer hours in both local machines and CI time. And this is since July, when we launched this first feature in the monorepo, okay? And the only thing you needed to do to onboard is add a secret to your environment, and that was it. Everything else was done automatically because of the golden path. So it's really important. And if you put this together with the other changes that we did about the parallelization, all in all, we have a 75% reduction in the CI duration, which you can see pretty clearly here. So the first time is before, so the first part of the graph is when we add everything sequential. Then the first drop is due to the parallelization, but then you will notice that still we had the build times going up before we were still adding lines of code, right? So the build times were going up, and then we did the test sharding and remote cache, and the build times dropped even more. But now you will notice actually they're not going up. They're now linear without increasing at all. So basically now we can add lines of code to our repo without build times changing that much. So this is how much of an impact everything did. And people are now very happy, but still this is where we are now. There's still some major pain points in our developer experience in Subito. The major one is that, yes, all the packages and React components, etc., are in the monorepo, but the applications are not. So once you upgrade the packages, once you publish the packages, you still need to go to the application and manually upgrade them. We can mitigate this with stuff like Dependabot or RenovateBot to open PRs automatically, but still it takes some time and you need to deploy your application, right? Which is not the greatest thing. So this problem is still yet to be solved. We have a couple of ideas on how to solve it. Maybe server-side render and micro frontends will do the trick if they were there and were stable, which they are not. But something we hope you can try in the future, because then basically you will gain the feature of being able to deploy independently of the main applications like we had before. Another solution could be to have applications themselves in the monorepo, right? So that when you change a package, also the application gets deployed together with the package and everything. We don't know yet. Maybe I'll be here next year talking to you about how we fix this, but it's still an unknown for us. We don't know yet. So all in all, I can tell you that monorepos are really hard to work with. As you can see, they might require a lot of work to make them efficient and run smoothly. They're not the easiest thing, even though we have it easy compared to other languages, which are much harder, but still they're not trivial to run. But I think that in medium to large organizations, they're really invaluable because of the reasons I told you, because of standardization, easiness to change, and discoverability of all the packages. Because those are the issues that you will have if you have a lot of people developing a lot of applications and a lot of packages. Lastly, I want to tell you, we ran an internal survey to front-end developers after some time with the monorepo to feel how they felt about the monorepo changes, and all of them told you that they liked it more than before, and especially they told that they could feel they could ship features quicker than before, so they can get to production much faster than before. They felt that the code quality was better and also much easier to maintain. They felt that the workflow has improved, as they don't have to do a lot of low value added tasks, a lot of boring and repetitive tasks. Now they can just focus on writing the code and the test and what they want, not tagging stuff. And most importantly, also troubleshooting was made much easier. They felt it was much easier to troubleshoot things, and they could catch bugs before going to production. And this is everything. Thank you.
Thank you, Alessandro.
Thank you.
Any questions for you? Questions? Questions about Subito after you search things? Okay, now it's working. Thank you. No questions for you. Okay, thank you.